Okay, so we're gonna go over the very last type of factoring that you can do to factor polynomials. In front of this flap it says quadratic form. You use quadratic form. Now I didn't take a picture. Oh, there we go. That's right. So here it says quadratic form. You use quadratic form when
It's 3.
all of your variables have even exponents. This is either 2 or 3 terms. Because remember, 4 terms you use what? Good. Groups, factoring by grouping. Now, what do you think it means when I say all of your variables have even exponents? Give me an example of a variable with an even exponent. Right, so x squared. What else?
X. 4th.
X to the 4th. X to the 6th. Is a plain x a variable with an even exponent?
Yeah.
No.
No.
Let's say 2 or 5 terms.
2 or 3. That's a 3, sorry. So, looking at our flap for quadratic forms, looking at the inside, notice example 1. How many exponents or variables do we have? 1, and what is the exponent? 4. So we go ahead and we use quadratic form. Now, all that this means is we treat this kind of like it's a quadratic. Now, I'm going to try something a little bit different with you guys. My last class, I tried to teach these actual steps here, but it seemed to confuse them. So I'm going to try a different way that may be easier for you. Looking at x to the 4th minus 16, what is special about this polynomial? Both of the terms are what? Even. They're perfect squares. And what is between the two terms? A negative. What can I use on 2 perfect squares subtracted from each other? What can I use? Difference of squares. So, what is the square root of x to the 4th power? What times itself equals x to the 4th power? X squared. The square root of x to the 4th power is x squared. What is the square root of 16? 4. Now, whenever we do difference of squares, you don't just write it once. How many times do you write it? Twice. And what goes between each one? 1 plus and 1 minus. Now, if this had just been a quadratic, I would have been done factoring, circle, okay, we move on. But this was a polynomial of power to the 4, and it splits into 2 separate quadratics. Can one of these be factored further? Which one? Can one of these be factored further? Probably, yeah. One of them can. Which one? Which one? So that's 2 perfect squares added together. Do we have a formula for factoring that? No. The other one. What or how could we factor the second one? Again, Difference of squares, guys. We just did it a second ago. They're both perfect squares. What is the square root of x squared? X. What is the square root of 4? 2. Do I write it just once? Twice with what between? 1 plus and 1 oh, that's too big. 1 plus and 1 minus. And then can x squared plus 4 be factored evenly? No. You cannot factor that evenly. You'd have to use quadratic formula on that to factor. I mean, to solve, sorry. So that's our answer.
That's a lot.
Is it?
Yeah.
Yes. All math.
Like, that's a lot of things that I just have to look for and, like, understand.
Okay, so we looked for difference of squares. What else did we look for?
I mean, like,
Wait,
when I
isn't it
see
next
that,
class?
I'm just gonna get confused because I'll just think of what the last unit was.
These are the same as like the first.
Yeah, literally.
But are these perfect cubes? What is a perfect cube? What does something being a perfect cube mean?
Even if
I can divide by 4.
You can cube root it and it's a whole number. So examples of perfect cubes are 1, 8, 27, 64, 125. What are perfect squares?
2.
Numbers that can be square rooted to a whole number. 1, 4, 9, 16, 25, 36. You have to be able to look at a number and understand, is 4 a perfect cube or a perfect square? Square. So are you going to use sum of cubes on this one? It's not a perfect cube. It's not a perfect cube.
Well, what's the difference between difference of squares and difference of cubes?
Okay. Difference of squares, everything needs to be a perfect square. Difference of cubes, everything needs to be a perfect cube. So, okay. Side note. What would I use on this one? Difference of squares, because 9 is a perfect square. Also, this is what? X squared, which is a perfect square. What would I use on this one? Difference of cubes, because they're both perfect cubes. What would I use on this one? Sum of cubes. What would I use on this one?
Sum of square.
Good. What would I use on this one?
Difference of cube. That was a guess. I do not know.
Sum is a plus, sum minus.
Right.
I know that.
So, like, where did we get all this difference from cubes and squares stuff?
Last class.
Oh, really?
Yes. Yes. Sum is when you have what between the two terms? A plus. So anytime there's a plus, it's going to be sum. Anytime there's a minus, it's a what? Difference. What about this? What would I use on that?
Sum.
Is sum of squares a thing? No. Can't factor that. Just a no. What about
No.
no? Why no? Why just no?
Last one is no.
Sum doesn't count.
Is this a perfect cube?
No.
Yes.
Yes. The cube root of 27 is? Is this a perfect cube?
No. Yes.
Yes. The cube root of x cubed is?
X.
Is this a perfect cube? No. So we cannot use anything on this. They're not all perfect cubes or all perfect squares. everything has to either be a perfect cube or a perfect square for you to use these formulas.
There should like be a chart that tells us these numbers can be cubed.
That's what we wrote on the front. Right? On the front. We went over. Okay. 1 times 1 times 1 is? 8 times, 2 times 2 times 2 is? 3 times 3 times 3 is? 4 times 4 times 4? 5 times 5 times 5?
25.
X times X times X? These are all perfect cubes. Do we need to go over perfect squares? What's 1 times 1? What's 2 times 2?
4.
What's 3 times 3? What's 4 times 4? 5 times 5? 6 times 6? And keep going. These are all perfect squares. What's x times x? X squared.
We write this in the quadratic.
Or in the back. Did we not write on the back in this class? Well, no, we didn't. Oh, we did.
Oh, we put this on the back.
Flip it on the back. Yeah, you can write them on the back. All right. So back to what I was trying to go over. Now, I am now going to factor example 2. What should you always look for first before you start factoring? A greatest common factor. Good. So, is there a GCF that goes into all 3 of these terms? X goes in. Yeah, you automatically say no, you don't even look. X goes into everything. What else? 3 goes into everything, yes. So I'm going to take a 3x out. What is 6x to the 5th power divided by 3x? 2x to the 4th. You subtract 5 minus 1 and you get 4. What is negative 51x cubed divided by 3x? What's 51 divided by 3? 17. 17. X to the 2nd power. And what's negative 27x divided by 3x? Negative 9. So now, I pulled out a 3x. That is as simplified as it can get. I'm ignoring it for now, and I'm just looking at the inside of my parentheses. Notice we have 3 terms, and all of the x's have even numbered variables. Even number exponents. So that's what tells me that I can just go ahead and act like this is a regular quadratic and factor it. How do you factor quadratics? Oh, you do know. How would you factor a quadratic?
X.
Oh, you do the X method. So let's go ahead and draw our X. What goes up top?
A times C.
Which is what in this case?
18.
Negative 18. What goes in the bottom? Which is?
Negative 17.
And what do you ask yourself about these 2 numbers?
What times what equals 18 and what plus what equals
Negative 18
Right.
and negative 1 or something?
Yes. What 2 numbers multiply to give you the top but add to give you the bottom? Good. Is it always as easy to find these numbers?
No.
Who remembers how to put this in your calculator to help you see these numbers?
It's like negative 18 divided by x.
Yep, negative 18 divided by x, the top number divided by x.
And then it's, I don't know.
Then you put
X.
negative 17.
plus X squared.
X plus
17?
No.
Oh, yeah, you can do
Y1.
y1. X plus y1. You get y1 by pressing alpha trace. Then you do second table to get your table, And what are you looking for?
Negative 17.
Where?
And then y2.
In y2. Oh, look. We got exactly what we thought it was. Negative 18 and 1. So that's how, if you ever can't find the two numbers, that's how you do it in your calculator to help you. Okay, so the trick to this is, notice, oh yes, what's up? Where did I get what? Oh, we pulled out that GCF, remember? Huh? I divided 6 by 3 and got 2. I divided 3x out. Okay, so notice this original function, this original equation was x to the 4th power that we're factoring, right? So that means when I'm writing down my factors, am I going to put it just a plain x, do you think? No. Normally, it's x squared, and I write down just a plain x. Now it's x to the 4th. What should I write, do you think?
X squared.
Yes. Half of x to the 4th, x squared. X squared minus 18, and x squared plus 1. Remembering, I must bring down the 3x. Is that the answer?
No.
What am I forgetting? You need to divide by the, not the 3x, the a in front of our x to the 4th power. Divide by a. So, I'm dividing both by 2. Does 18 divided by 2 come out even?
Yes.
What is it? You're right. What is it? Does 1 divide 2 evenly?
No.
So what should I do with that 2? Kick it to the front. No, not today. Mm-mm.
Don't we have a quiz next class?
Next. Next class. It's not a quiz. All right. Now look. Shh. Am I done factoring?
Now it's when you divide by 3. No, you're done.
Take a look at all 3 of these. Ah, what did we just go over? Difference of
Squares.
squares. How can this be split? What is the square root of x squared? What's the square root of 9? And I write it twice. What's it between both? One as a minus, one as a plus. I know, this one's a long one. That's it. All you did there was difference of squares.
Sing with us, Miss Sarah.
I do not know this song. Either that or you're singing it poorly. What? No, it doesn't matter which order. Any questions on either of these? You guys go ahead and over here try 6 and 7.